Hello. Now we are going to look at how parallel lines, like our orange or red lines going across here, they're parallel, they have their arrows to show that they're parallel, how these parallel lines break up lines that cross them. These are called transversals, lines that cross a bunch of other lines. How these lines are broken up in a particular ratio by the parallel lines, and similarly, how parallel lines break up the sides of triangles. So if we have the base of a triangle or one of the sides of a triangle and we have a line going through the triangle that is parallel to that side, it breaks up the sides of the triangle in a particular ratio. So very similar connected type ideas. So parallel lines break up any line that crosses them in the same ratio. In this particular example that I'm giving you here, we say that we have equal transversals. That means that this blue line here, crossing our parallel lines, has been broken into two equal parts, both 7 units long. And we show that they're equal lengths by putting a single line across them. You could also put double lines. So long as it's the same symbol on both parts, it means that this bit is the same length as this bit. And it's labeled as a length as well. It's 7 units in this case. So these are equal transversals. Well, what does that mean? Well, we know that the ratio is the same each time for whatever line at whatever angle crosses these parallel lines, they get broken up in the same ratio. So if this length is the same as this length, that means that this length must be the same as this length. But we can be more general than that because it really is any ratio. Whatever ratio these two lines got broken up into is the same as the ratio that these two bits of the line, this line, would get broken up into. So we would have the ratio of 4x all over 8, just to put the variable on top, 4x all over 8 would have to be the same as, this ratio would have to be the same as 7 over 7, which is trivially 1. 7 into 7 goes once. Any number divided by itself is 1. So we would have 4x all over 8 would be equal to 1. In this particular case, equal transversals are a fairly common question, so that's the reason for this particular example. But as I say, this is true for any ratio. Any way that, so if this line was twice as far up this way, then we would have had a ratio of 2 is to 1 going that way. In this case, we have 7 is to 7 or 1 is to 1. So we end up with 4x x is equal to 8, and to find x we just divide by 4. 4 divided by 4 is 1, in the same way as 7 divided by 7 is 1, and we end up with x must be 2. And you can see that this has to be the same as this. If 4x is equal to 8, well, x has to be 2. So what does this look like for triangles? Very similar logic, but it can look a little bit different because we have the parallel lines sitting inside of triangles, or specifically a line through a triangle that's parallel to one of its sides. It does exactly the same thing, but it can look a little different. So for triangles, this means that any two opposite sides are in the same ratio. And that is actually quite broad. So let's look at a few different ways that we could find the side y. It means that this side divided by this side is in the same ratio as this side divided by this side. Same way as, or similarly to how we would have done this here. So we'd have y all over 3 would give you the same ratio as 4 all over 2. So we would end up with y all over 3 is equal to 2. Multiply both sides by 3 to get y by itself. We would end up with that y must be equal to 6. That's not the only way that we can do this. We could treat it exactly the same way as we did this question here. So if we imagine there was a third parallel line going through the tip of that triangle, so it looked a little bit more like our first example, we would have 3 all over 2 must be the same as y all over 4. 7 all over 7 must be the same as 8 all over 4x. So we could break it up that way. Just to be clear, the question is answered here. The point is to show that there are lots of different ways that this relationship plays out. So this one is identical to this argument here. y all over 4 is equal to 3 all over 2 in the same way as 8 all over 4x is equal to 7 all over 7 in what we did here. So rearranging this, we'd get both sides over 4. So we would end up with 6 all over 4 is equal to y all over 4. And then we would multiply both sides by our lowest common denominator. And again, we would get 6 is equal to y, or y is equal to 6. We can also do it in terms of the total. We can also do it in terms of the total sides being the same. So the side total here is 2 plus 3 is 5. And the side total here is just y plus 4. We can't simplify that yet. So y plus 4 all over 5 would be equal to 4 all over 2 or y all over 3. You could do it either way. We'll do it 4 over 2 so we don't have quite so many letters going on. But either would work. And we would get the lowest common denominator, which in this case is 10. So we need to multiply here by 2 over 2, multiply here by 5 over 5. So get the lowest common denominator of all of your fractions. So you would end up with 2y plus 8, multiplying in that bracket, all over 10 is equal to 20 all over 10. Multiply both sides by your lowest common denominator. Essentially all you're doing is saying I can now compare my numerators. And we end up with 2y plus 8 is equal to 20. Rearrange to get y by itself. 2y is equal to 12. And divide both sides by 2. Y must be equal to 6. Now, why am I doing this in so many different ways? It's to, one, highlight that it is possible to do it. This relationship is quite general. So long as you are getting the ratio of any two opposite sides, it must always work out to be equal. So you have a lot of options, and it's important to train ourselves in that so that we can see all of those options if they give us a question that's slightly more awkward. So we have all of these options for the different ways. So long as we are getting the ratio of opposite sides to our parallel sides, to our parallel lines, then we are going to be fine. The ratios are always going to work out the same. So what can we do here? Do we have any options for working with our parallel sides? So here we have a side of a triangle. We have another side that is another line going parallel to that side. So our opposite sides here, x and 2, the ratio of them is going to be the same as, say, 12 and the total side length here being 8. So actually that's the first one I have written. So we have x all over 2, this side all over this side must be the same as 12, the total length of this side all over, what's the total length of this side? It's going to be 6 plus 2 is 8. So again, this is 2 plus 6, that's where I'm getting 8 from. It's going to be the same as 12 all over 8. And the 12 is on the same side of the triangle as the x is. So that's how you tell which way up this has to go. It has to be 12 all over 8 because x and 12 are on the same side of the triangle. So we'd have that we can actually simplify this fraction down. We have a common factor of 4. So we may as well simplify that. So x all over 2 is equal to 3 all over 2. So now x must be equal to 3. But we can write that mathematically by multiplying both sides by our common denominator of 2, because 2 divided by 2 is 1. So we have x is equal to 3. 2 divided by 2 times 3 is 3. So that's one way to do it. Another way that we can So one of the other options that we have would be perhaps to define our length here. How would we define this length if we know the total is 12 and this bit is x? Well, that means that it's the total length, pardon me, it's the total length of 12 minus the length we don't know, x. So this bit in blue, well, this bit divided by 6 must be the same as 12 divided by 8. So we could solve for x that way as well. So this is just another option, another perspective that we can take on comparing the two sides. And the more we are able to spot different ways of doing this, the better we are. Because for more complicated parts of geometry, spotting these patterns can be quite challenging. So the more we take this opportunity now, the better off we will be. Actually, for variety, I think this would work. 12 over 8 will give you the correct answer. And I think I will do it as x all over 2. So comparing x all over 2. And again, these two are on the same side. They are both on the top of the fraction. These two are on the same side, so they are both on the bottom of the fraction. So it's important we have that correct. So how are we going to find the value of x now that we know that these two ratios must be equal to each other? Well, we can get the same denominator, so we can compare them. So I have to multiply here by 3 over 3 to get the same denominator. My lowest common denominator of 6 and 2 is 6. Should have that down. LCD is equal to 6, and my LCD here was 10. So I have all over 6 is equal to 3x all over 6, and I can now compare the numerators because my denominators are the same, but just for tidiness, I can say 6 divided by 6 is 1, and 6 divided by 6 is 1. So I have 12 minus x is equal to 3x. Now I want to solve for x. So I want x's on one side, numbers on the other. And I've divide both sides by 4. And I get x must be equal to 3, or 3 must be equal to x, and that should have units because it is a length. So that is what we need for our transversals of our parallel lines, and how that can affect the ratios of the sides of a triangle. And that is what we need for now.